All right. So here we are, guys. It is December 4th for us, and we are continuing on today with 3.5, where we're looking at zeros of polynomials. Now, just as a quick review, yesterday we used this set of steps. I'm going to write these much shorter. I'm going to rewrite the steps. That's calculus. I don't know what's going on there. Oh, weren't you guys supposed to try a problem?
Oh, we tried it. Sure.
Oh, okay. So we're going to retry this together then, I assume. Did you really try it?
The problem you gave us last night?
On B, did everybody try this problem? Okay. So I'm just going to write the same stuff, but much more concise. Step 1, if you check your notes, it was M behavior and what?
Find factor.
And factor. Okay, so I'm just shorthanding these. Step 2 is find roots. And anything else?
Place roots and
Put on number line. And then what else did we say? Okay. So check interval. Check interval. And you could say check region. It's going to be the same thing. And then step 3 is simply sketch, right? Okay. So the only reason I'm having trouble with this is because I think in first hour was 5 steps, and I just wrote it as 3 steps yesterday because we can do it. Okay. So this problem here was really nice. And really nice depending. It's nice because it's already factored. Now, I asked you guys to write the roots 3 times if it showed up thrice. Or write it 2 times if it showed up twice, and so forth and so on. Okay, I am done with step 1-ish. Did we talk about the end behavior of this one? Okay, on the count of 3, you're going to give me one of the 4 moves. What do you guys think the end behavior is here? Are you sure we didn't talk about this?
We talked to us about it.
Okay, so it can be hard to tell. In the end, we don't really truly need it right now, but I do want to show you. If I did this, this is going to be x cubed plus a bunch of other stuff, times x squared plus a bunch of other stuff, which is now x to the 5th, times x plus some other stuff. I'm going to get x to the 6th, and I know it's going to be a positive 1x to the 6th, which is how I got this in behavior, because it's positive and even. Now, if you hear that and you go, I don't understand what you just said, it's not the end of the world, because we're going to get the same answer here. So what do I do with these? We found the roots, done. Put them on a number line. So let's do that. Now, the hardest part, and I don't know if I really think it's the hardest part, but the easiest place to make a mistake is if we don't write these in order, our problem is dead. So I need to make sure that, and you also need to make sure that we put them in the right order. Of these 3 options, which one's the furthest left?
-2.
Okay, so I'm not even going to put any thought into the scale, just so you know. I will never think about the scale. What's the next number that shows up in my roots? A 1. And the next is a 3. Okay, I'm not going to put another mark on here, ever. So I'm talking about, what's the name of our function? G, or g of x. I'm okay with either. I just want to make sure it's clear that this is what we're plugging into. Now, for this first one, how many regions did we split into here? I think there's 4. 1, 2, 3, and 4. There's 4 regions here. Okay, so I'm cool with that. And let's just check. Give me something in this region. Any x value. So I'm going to draw the arrow and point to it. And I'm actually going to write it a little bit more. I don't remember how much I wrote yesterday. But I just need to know g of -3. And do I really care about the number? No, all I care about is the what?
The sign.
The sign. So if it wasn't clear yesterday, and I guess I can just look and see how much did I do, I would rather not have to write it over and over, especially since we have the factored form here. When I plug in a -3, where am I plugging it in? So let's look at this one. What's -3 plus 2? A -1. And if you cube it, what is it now? So it's a negative though, right? Okay. And how about this one? If I plug in a -3, I get -4 squared is a positive. And then this one, if I plug in a negative, did I write this down wrong? Weird. No, I'm good. Okay, never mind. -6. Weird. I got confused there for a second. I was looking at this and trying to think of why I wrote a 2, but the 3's here. Okay, so we're here. What's a negative times a positive? Times a negative. Okay, we're going to try it again. Like, no, you're good. Negative times a positive is a negative. We're all at negative right now. So now it's a negative times a negative. Okay, so what am I going to write here? Positive. Don't think, are you trying to take a shortcut? I think I know what you're going to say, but I always assume. Can I tell you and you'll just tell me?
Yeah.
I think you're about to tell me you think this is going to be negative and positive and negative. Okay, maybe. Don't assume. Let's check. Okay, pick a number between -2 and 1. The easiest number, preferably. 0. Now, we're going to show you wrong here. 0 plus 2 is positive. Cubed is a positive. Do we all agree? So I'm going to write the same thing on to change the color. I don't know why that came out so funny. Change the color. We're just thinking about g of 0 at this point. 0 plus 2 is a positive. Cubed is still a positive. 0 minus 1 is a negative, but gets squared, and it's a positive. 0 minus 3 is a negative. Did I do something weird? Nope. Okay. Is a negative, which makes me think this one is a negative. Okay, maybe we haven't proven you wrong yet. Maybe we're about to. Pick something here. Okay, let's try it out here. What's 2 plus 2? And cubed, does that give me positive or negative? Positive. What's 2 minus 1? Squared is a positive. 1. I'm okay with that. And what's 2 minus 3? What's a positive times a positive? Times a negative? It didn't work. There's a reason it didn't work, and it's awesome that it didn't work, and we're thankful it didn't work. Maybe not yet. Okay, one more out here. I would bet money that it's going to be positive. You could pick 4. Could you be obnoxious if you wanted? Everybody can be obnoxious if you want to. Yeah, like it sounds so silly, but if I pick 100, there's no doubt in my mind. Is this positive or negative? Positive? Is this one positive or negative? And the last one? If you pick an obnoxiously large number, you don't even really have to think about it, and you can only do that on the outsides. Okay, from just this, I can get a sketch of my function. Now, I haven't actually calculated any values, right? And I can get better graphs if I do actually get a couple values, but if all we're after is just a very rough sketch, this should suffice. So let's look here. If I wanted to graph this, I'm just going to make my lovely x-axis and y-axis. I need to include all the way to -2 and up to +3. So I might as well just go -5 to 5 because I have the grid already. Now, we've done all the hard part. All the hard parts are already taken care of. What numbers am I going to put on here? Because I made the claim that I don't have any numbers, but I do have a few. I get a -2 on the x-axis because that's an x-intercept. So I'm going to plot it. Here's my -2. Then I get a 1 and a 3. These are the x-intercepts or the roots that we identified. So now we can just use this. If it's positive or above the axis to the left of this, it's never going to come back down. Does that agree with the end behavior that we thought out? So I know that here it's going to go up forever, and I'll add more stuff to this in a second. And then between -2 and 1, it crossed, right? So it went down here somewhere, and I'll add more stuff to this momentarily. And then it hit 0, so I guess I'll just hit that now. And then where does it go? Does it cross or does it stay negative? Does that do it?
That's allowed.
Seemingly. Only way it can happen, I think.
That's how I drew it.
And then it crosses, right? This is what I think the graph looks like. Now, I do want to highlight here. It doesn't tell me this is exactly what it looks like, because another graph with the same characteristics could do something like this, where it just comes like this. And I missed it, but I tried. It could come way down and then just barely dip down. Like that's the same stuff. Now, the specifics, we don't get the exact same, but all the other parts are the same. How close do you think we are in Desmos?
Not really close.
You don't think so? Did we graph this one yesterday?
No.
I think we graphed the other one, right?
Yeah, we got
I don't know. Hopefully we stumble upon one that's just like perfect. Somebody read the function to me because I lost it already. So I just heard x minus and x plus.
X plus 2.
Okay. Where are you looking, Kian? Where are you looking that you said minus and then reiterated? Did you have it written down wrong the whole time? This problem did not make sense to you, I imagine. Okay, x plus 2 cubed,
X minus 1.
x minus 1 squared, and x minus 3. Is this W-shaped? Sort of? Like it's hard to tell. But,
Yeah, we were not close.
so you say that, but I still don't know that I agree with you. Does it go down and then turn around? I'm just really zoomed in. Yeah, like I could switch it. Sorry? The scales, I mean, I don't have a Y scale at all on mine. Like I never even thought about Y values. So yeah, definitely. But we can switch the scale so it looks a little bit nicer. It'd be a weird scale. But like we only went from -5 to 5 on the graph, right? So we'll go -5 to 5. Does that look a little closer to what we just drew? And it's not perfect, but that's okay. Does it have a W shape? And I can tell that based on this. Now, this part of the problem can be kind of a bummer, I think, because this is the hardest and longest part of the problem. It would be real nice. All right. It would be real nice if we didn't have to do this, right? So maybe there's a way through it. Okay. We've done 2. I want you to show me one more real quick, and then cool. You guys are killing me. Okay, here's the deal. Don't get rid of this example because I'm going to use this again in a second. Just like we did, if you have roots that repeat, do them more than once. Like if it shows up twice as a factor, write the root twice. There's a reason I want this, okay? So just like this one, I knew that this was 3 times it showed up. So I wrote -2, -2, -2. Write it the same. Okay, cool. One more. You guys are going to help me make a function. Where do we want the x-intercepts? Just where do you want the zeros at, the x-intercepts? So 1 at 2, so I'll save that one over here. So here's x minus 2. I'm cool with that. Let's say that one's squared. Let's do x plus 4 squared, and I'm going to do x minus 1.
How do you have 2 squares?
That's okay. X plus 4 squared, x plus 4 times x plus 4, and x minus 2 and x minus 2. Like, it can happen. Okay, and then I'm going to add, this one's wonking out of order. We're going to add x, just for fun. So we have, how many total factors? Like, I've only written 4 of them, but how many are there? So that's, if you don't know, that's okay, because like we want to know. When I say squared, if I wanted to, and I don't really want to, and I don't want you to, except for this time if we need to clear it up, what does it mean if I said x plus 4 was squared?
X squared plus 4 squared.
So real quickly, are you a freshman?
No.
What you just did is called freshman stream. Doesn't work. When freshmen learn to FOIL or to like to distribute, everybody wants to do this. But I don't think that's true. Because it's this. No, you're still wrong. Which is okay because everybody wants it to work nicely rather than doing this. It's really x squared plus 4x plus 4 is what it is. But because you have to FOIL it, right? This I call freshman's dream. That is not true. Don't do that. It never works. Okay, there's a grain of salt that's not quite true there. It never works for you in high school math. Okay, like for real, it won't. Unless you're doing high school math in mod 2, which you don't know what that means, so you probably aren't. And I'm your teacher. Yes, exactly. Okay, check it out. So modulus. Do we agree that this is really what it means?
Sure.
Okay, and what does x minus 2 squared mean? We'll see. Okay, so when I ask the question, how many factors are there? I can see that I've written 4 things down, right? But how many were actually there? And notice, I don't think I really had to do that. There were 2 right here, and I can tell that because there's a 2. There's 1 here, so we're at 3. There's 1 here on the x, so we're now at 4. And here's 5 and 6. I can see all 6 of them written out here. My hope is that we don't have to do this every time. But in reality, if you do, that's fine. It's not a huge deal. Okay, I want you guys to do the same thing that we just did. I'm going to pause it for a moment. We're going to find the roots and list them however many times they showed up. You're going to put them on a number line, and then you're going to check each interval. You're going to get 4 different regions on your graph. So 4 things that you have to check. Cool. I'm going to give you a minute. I'm going to take attendance, and we'll do it here shortly. So as we're looking at this, you guys are going to help me. I'm feeling pretty yellow. Roots. What roots do we get from this factor or these factors? X equals -4. And it showed up how many times? 2. So I'm going to write it twice. And there's a reason, I promise. -4 and -4. What root do we get from this factor? +1. Good. It only showed up 1 time, so I'm only going to write it once. What root do we get from this factor? 0, and it only showed up once, so I'm going to write it once. What root do we get from this factor? 2, and it showed up twice, so I'm going to write it twice. We have a 1, 2, 3, 4, 5, 6. It's a 6th degree function is what this is. Okay. Now, when I'm looking at these, we're going to zoom out in just a minute. We're going to look at this and the previous one together. But I'm going to put these numbers on a number line. And again, as long as they're in order, like correctly on a number line, things will work out nicely. This will be the last time we have to evaluate a bunch of different parts because we're going to work out a shortcut here in a minute. What's the furthest left out of all these? Okay, so there's -4. What's the next one? Nope. 0. And the next? 1. And the next? 2. So I've made 4 marks on this, right? 4 roots. There are 5 regions. Okay. Pick something in this region. -5 works fine. Would -50 also work? And I'm going to use -50, and like legitimately, I don't really care if it's 50 or 500. I do it because it's obnoxious and I don't have to think about it. This would be a negative, but I squared it, so now it's positive. So I have a positive. The second factor right here is going to be a what if I plug in a -50? So I got a positive on the first one because it was squared, and then I got a negative, and then I got a negative, and then I got a, I think negative times negative is a positive times a positive, it's all positive. So there's F, it's positive there. Okay, don't yet. Here about 10 minutes, you'll be able to take a shortcut. We won't have to do any more. Give me a number here between -4 and 0. -2 is a good choice. Like there's no bad choice as long as it's between these. I could pick -3.999999 if I wanted. I don't, but you could. And let's check. I know that first term is always going to be squared, so it's always going to be positive. This one would be a negative. This one would be, so careful, why positive? So time out, hold on, you said +2, but we only have one that's positive. Okay. So let's back up real quick. That's going to clear up confusion. But do we agree the first one's going to be positive when I square it? Okay, the second one, -2 minus 1 is negative. -2 is negative, okay. And the last one is going to be what? Guaranteed. How do you know that without thinking it? Okay, square. Like you had to think still, but cool. Okay, here's where this becomes tedious and awful. Pick something between 0 and 1. It's 0.5, right? Okay, so yuck. But I want you to really notice that I am never putting anything else on the number line. So let's do some thinking. The first one's positive, and I guarantee it because it's squared. 0.5 minus 1 is negative. 0.5 is, ooh, we're on this one. If I plug in just 0.5 for this x, this is positive, right? Okay. You might have misspoke, but if it was just wrong, then I'm not sure. What happens when I do a positive times negative times positive times positive? It's a negative. Okay, pick something here. 1.5, that's fantastic. And I'm going to switch colors. I'm about out of colors. This part sucks, right? It's not terrible. There's worse things that you've done in math. Is this better than making a table with 50 points still? You really don't think so? Like if I said make a table here and I said use -5, -4, -3, -2, -1, but we were to get 0.5 and -1.5, like you'd rather make this table? Okay. I agree. Yeah, but good luck getting me angry. I'm pretty chill. Do not. Yeah, we're just gonna pretend like I didn't say that. Okay. Check it out. If I plug in a 1.5, it's a positive and a what?
Positive.
Positive. Cool. And this one is?
Positive.
And the last one is?
Positive.
So everything is? Positive. I agree. And one last one. What number do we want to pick between 2 and infinity? So can't use infinity because infinity is not a number. But I don't know, 50? Okay. I know it's going to be positive, and a positive, and a positive, and a positive. It's all positive. Thank you. Okay. We have all this information. Cool. Let's graph it, or at least sketch it. Now, I'm never going to pick a y-scale, ever. If we're sketching, I just won't. So cool thing is that I have the grid paper up on my board. You guys don't necessarily. I'm always going to begin the same. I'm going to start by putting the roots on there. And this function was yellow, so I'll do it yellow. So I had a root at -4, and at 0, and at 1, and at 2. Okay. I don't know the way that your brain wants to put all this together. In my mind, I like to just start at one side and then work my way over. But maybe we don't have to do that. What I notice is from -4 to 0, it's positive, and then it switches. So right here, it crosses. I know that because at 0, it changes from positive to negative. At this point, it was positive on both sides. So I think it probably must come down and just barely touch it and then turn back up something like this. Okay. And then it was negative between 0 and 1. So here it is being negative. And then it crosses again, right? To go positive. And then it bumps back down to touch it, and then it comes up again. This is a rough sketch of what we just did. Okay, as always, we're just going to check because eventually, if we keep doing this, and we won't have like a million more examples, so hopefully we don't keep doing this, but we're going to get one that winds up pretty close. I don't know if it's this one because we just made it up. X plus 4 squared. And can you guys hook it up? Because I didn't write them all down. X plus 4 squared. What's my second factor? Just once? And then an x? And then? So maybe until I change the y's. But check it out. We can make it look close, I'm sure. I just want it to go to 1,000 and from -1, we'll say -50 or 40. That's fine. And we're going to jump by 50. And we'll just see if I can zoom out. That looks a little closer. Does that look about like what we just did? Like, kind of, right? Does it come down and then pop back up? Yep, it does the same thing. And again, I just want to stress we could get better points if we wanted a better graph, but we don't need it. Okay, here is what I want us to try to generalize. We're going to learn a new word. Cool. Do you guys want a quick brain break? Okay, so real quickly. Okay, we've done 2 examples where, 3 examples really, and I just want to look on this first example, and I'll zoom in if we have to, but you guys have the same examples in your notes. How many times, like, do we all agree I crossed the x-axis right here? Yeah. And that root showed up how many times? So that's at -3. It showed up once and I crossed. Okay. How many times did this root show up? 0, right? And I crossed. This one showed up once. So we're just going to take a little tally here. Number of times, and you don't have to write this down because we'll generalize this here in a second. And then the root shows up is what I'm talking about, and what happens. So if it shows up once, based on just this example, what does my graph do at that x-intercept? It seems to cross, right? Okay, so let's check down here. This one and this one, it crossed, right? So that's at -2 and 3. So it crossed again if it showed up one time, which is what this did. How many times did this show up?
3 times.
And it crossed still though, right? So at 1 time it crosses, at 3 times it crosses. Huh.
Odds cross.
Well, let's see if that stands the test. How many times did 0 show up? 1 time. Now, I didn't do it, but I think it's reasonable. Let me check that real quick, because if you didn't hear Declan, he said, so if it shows up an odd number of times, it crosses. Well, I don't know, maybe. Let's just see what shakes out. I'm going to make a factor, it's x, and we'll make one that's x plus 2. And let's say this one showed up 3 times. At -2, does it cross?
Yeah.
You say no, Jade.
Oh, yeah.
Have you changed your mind?
Yeah, because it goes.
Well, give me another number that you think it'll cross with. 1?
11.
1 it crossed. 3? it crossed? 5, 11, 1,833. Is it going to cross? It certainly did cross.
Whoa.
What's happening? And you noticed it right away. And awesome.
It gets flatter.
So before that, all I care about is how do I know if it's going to cross or not?
If it's even or odd.
So help me out with that. If it's what type of number will it cross? If it's odd. Now it stands to reason then that we would conclude that if it's even, it won't cross, which here the language varies, but let's check it out. I need to find anywhere on these graphs. Is there any graph that we've done where it did not cross? Like this one, I think it didn't. Weird way to say that. It did not cross there, right? What would you guys say it did? It didn't cross the axis.
Not as close as
So it does touch it. It physically does touch it. My language that I use is I think that to describe this, I would say it touched and it turned. Touch and turn. Now, first hour decided U-turn. My pre-calc class this year, for whatever reason, they want to use the term bounce, which doesn't really make sense from this one, but if we look from the other side, it would. I like touch and turn. That's probably how I'm going to refer to it. How many times did this root show up? Careful, don't.
twice.
So that's at 1, right? How many times did 1 show up as a root? And it touched and turned around. How many times did -4 show up as a root? And it touched and turned, right? It stayed the same. It went positive, it touched 0, and then it stayed positive. It had to turn around. That's the only way it can do it. What you guys have just worked out, and the pattern's clear, right? Once we look at it there. Okay, we have just learned like the most valuable shortcut. And it's a shortcut that we'll use again this year, but it's also a shortcut that I use in calculus, and we're using it in calculus right now. It's a shortcut we use throughout this year. Like, we're going to use this over and over and over. So we get a new word right off the bat. Our new word that I don't think you guys have ever seen is multiplicity. Multiplicity. Now, we've been talking about the number of times that roots show up, and do you guys agree that some of them that we just saw that showed up multiple times? Like, for example, if it showed up twice, that's multiple times, or thrice is multiple times. That's the multiple part of this, multiplicity. Now, for this, easy way to define this, and there's two different versions, but they're the same definition, but it can be hard to make sense of it. As the shortest definition, multiplicity is the number of times a factor, and I'm going to put this one in parentheses because it's the same thing. We can look at the factors and how many times they showed up, but it's going to be identical to that root and how many times it showed up. The number of times a factor, or the root, whichever one you want to think about, shows up. Now, there's only two possibilities for this. A root or a factor can show up once or thrice or 5 times or 7 or 9 or 11, doesn't matter. It can be odd number, which if it's odd, what did we just determine? If odd, the graph of, and I'm just going to call it f of x, even though it might not be f every time, crosses the x-axis. Now, for our purposes, if we're doing our number line and not really truly graphing it yet, we don't have to necessarily think about it crossing the x-axis. If it's odd on the number line, and I'm going to put this here just as a follow-up, on a number line, if we're doing this like we have been, no sign change. No change in sign. And we'll do another example of this here in just a minute, but we're going to branch it out to a bigger problem. Okay, there's another side of the statement that we need, though. If my multiplicity, which is just the number of times that something, the root or the factor shows up, if it's odd, it crosses the x-axis, and there's no change on the number line. What if it's even? So there is a change for sure, but what's the opposite? And it's a weird statement, but what's the opposite of crossing? What's the language we used? The graph of f touches and turns. Of f of x touches, and when I say it touches and turns, what does it touch? Good. The x-axis and turns around. Okay. Now, in the context of our number line, all that means is on number line. Whoa, I'm backward here. We're going to look at this because I have a huge issue with the way that I wrote this. And we're going to pause right here until you guys are caught up. Because I'm pretty sure that we are all going to have this because nobody noticed it. Anybody notice a huge mistake that I made in purple on the top one? If it crosses, and I was positive, what am I now? Did I change sign? We need to destroy the word none right there. I don't know what I was thinking. I think we all said it the right way, and I might have even said it the right way when I was writing it. But if it's odd, it crosses and the sign does change because it crossed the axis. It went from positive to negative or vice versa. On the number line, if it's even, where it just touches it and turns around, does our sign change there? So for example, if I'm thinking about, I'll even think about the graph. If this is a root and it was positive and it touched and turned around, is it still positive? Okay, no change here. No change in sign. And I don't know if I said it incorrectly or not, but please double check, triple check, quadruple check that you've gotten rid of, if it's odd, it has to say change in sign. Sorry about that. I'm glad I caught it. Cool. Now, for these, we could graph another function, but I don't know if we need to necessarily. Instead of graphing a whole nother function, I think that we should just see one more type of problem and then use the last 15 or so minutes to just kind of work on stuff and try to avoid some homework. Cool. Is it Wednesday or Thursday? Thursday. Cowboys played a game. I'm doing so bad in picks this year. I picked the Cowboys tonight. Did you guys? Yeah. Ooh, I picked the Cowboys to beat. Are you a Lions fan also? Yeah.
So, but
Fair. I liked him a lot. I'm fine with the Lions. I liked him. I like Matt Stafford, who I really like. But he's not with the Lions anymore. Anyway, we'll come back. So check it out. We're going to solve the following. And we're going to make sure on this one, I didn't say what we're solving, so I'll just use these ellipses, ... And let's check it out. I want to know when is it true, and I should probably get my algebra book so I can give us an example that's not awful. So here we go. I want to know when is it true that the following happens. And on A, we have 2x cubed plus 12x squared plus 12x. And I want to know when is this less than 0. Now, it feels like a very different type of question, I think. But what is it? If I say a number is less than 0, I'm telling you that it's a what type of number? Negative, which the stuff that we just wrote, if we put it on a number line, can we decide where it's negative? So if you're not sure about that, I just want you to look at what we've done. If I put roots on a number line, can I tell you where the function's negative? Like we just did this over and over, right? So yes, definitely. Now, this one's going to be a nice review problem. We're going to treat it essentially the same. It's been a while since we did these, but because we're doing a cumulative final anyway, it's good review. What does it mean again, less than 0? Good. If you remember when we did these before, I encourage physically write down what this means. We are going to look for the places where my graph is negative. Now, I don't actually have to graph it. All I have to do is be able to figure out if it changes, where would that happen? And the easy answer for us is at the intercepts, the x-intercepts, wherever they are. So it's no different, except we're not going to graph it. We just need to find out where it's negative. So how do I do this problem? How do I find what numbers to put on my number line? I'm not going to just wildly start. We've been doing this. It feels like a different problem, but I promise it's not. How do we decide what numbers to put on the number line on any of the last several examples? Find the roots. So what should we do? Let's factor it. So step one is, I'm not going to write the steps because it's like the same problem. We need to factor this because we need the roots. Are we doing it together, or you guys want to try to factor on your own here? Okay. Where do we start factoring every time? Is there anything that goes into all three of these? 2x. What does it leave behind? So x squared, I think, because 2x times x squared would be x cubed, plus 6x plus 6. Now, here's where it's going to get weird. Because I already made this statement that means negative, because I'm looking for the roots, the intercepts, the zeros, I'm going to change from an inequality to an equals, so I don't have to think about stuff any differently. Whatever it is, I'm just going to look for the negative spot at the end. Okay, so this part is factored, and I can't factor it anymore. It's going to keep coming along until we're done. How do we factor this trinomial inside? Let's try. Find me factors of 6 that sum to 6. 3 and 3 make 9 when you multiply them. Negative 2 and 3 multiply to be negative 6, not positive 6. There aren't. 1 and 6 won't work. 2 and 3 won't work. 6 and 7 also don't work. We can, but we can't use a shortcut. What is the, say it again? Negative 2 and negative 3 add up to negative 5 instead of plus 6. We can't find them. They don't exist. I mean, they do, but we don't know them because they're ugly. You've said it a couple times, Kian, but I don't know if everybody else got it. The quadratic formula. Okay, well, looking at this, we're going to have to do some scratch work. Can you tell me what value of x makes this factor 0? That one's easy. It's 0, right? Okay, this over here, I'm not going to do scratch work because we can't find these numbers, and we'll just make a sad face. Well, the good news is we don't need them because we can use quadratic formula. If you remember the quadratic formula. Pretty sure it's written on the board up there. All right, here's the deal. I want you guys to find me the other roots real quick. Do it to it. You're going to plug into the quadratic formula with 1 and 6 and 6, and you're going to find me the other roots. If they're real, we'll put them on the number line. If they're not, we won't. I'm going to give you a moment. That is a 4AC. So we found 2 more roots just now, and I did not really work through it super in detail. Most people are going to get the negative 6 plus or minus root 12. With a little bit more simplification we get here. Okay, so here's the big question. We're going to try to do this without calculators, and we just did all of this without a calculator. Is root 3 bigger or smaller than 3? It has to be smaller, right? Because something times itself equals 3, and if it was bigger than 3, it'd be bigger than 3. Okay, so I know that root 3 is smaller. Which one's further left? Negative 3 plus something or negative 3 minus something? So the minus is the first one, right? So like I know it looks ugly, but I promise we're not going to have to use a calculator for any part of this. 3 numbers go on my number line. Negative 3 minus root 3. And then this one's super counterintuitive. But we already decided that root 3 is smaller than 3. If you have a negative 3 and you add something smaller than 3, is it still negative? Like, let's pretend, I don't think it is, but let's, like, it'd still be negative. So our next number is negative 3 plus root 3. And our last number is 0. Okay, here's the multiplicity's value. Because if you're going to actually try to pick something, if I asked you to pick something between these, it's kind of ugly. There's an obvious choice, but if you don't see it, like, I wouldn't use negative 1. I don't think it's, maybe, I don't know that. Negative 3 is my choice, because negative 3 must be between something, whatever I add or subtract from it. But it can be hard to see that. Turns out, maybe we don't care. I'm going to use that multiplicity idea. Each of these roots showed up how many times? Which means I know at each point it crosses. It crosses at all of these. So let's just pick an easy value to start. I can pick something all the way over here, or something between, or in here, or something here. Are you pointing at this one? Pick something here, between 0 and infinity. 1. Everybody okay with 1? You can pick 10 if you want to be obnoxious. But if we pick a 1, and I'm just going to plug it into the original since you don't have a full factored one. 2 plus 12 is, don't care about the number, all I care about is the sign. Is it positive 26 or negative? Okay, so it's positive. If this root had a multiplicity of 1, which is an odd number, it crossed here, which means if it was positive, if I cross it, it's now negative. And we don't have to calculate all these anymore. We have a shortcut through it. We don't just assume it alternates. It depends on what's going on. What is it here? Positive again, because that root Each one of them, all of them, show up once, which is odd, and it crosses. And over here, negative. So if our question from the beginning was just when is this less than 0, can you guys tell me the places where it's less than 0? So could we say leftmost just for now and this one? Okay, so let's make that a little bit more formally. This is true, and we're just going to write our answer in our lovely interval notation. We're going to say this is true in our original when x is in some interval of numbers. If I wanted to sketch all of this interval, I don't have infinity to do it, but it starts at negative infinity, and it works how far? In the set of. So this is what's going to help me avoid thinking that this is an ordered pair. So x is in the interval, or the range of numbers, between negative infinity, and how far do I keep working this way? Until I get to where?
Negative 3 minus 3.
Good. Then I don't touch it, right? Because it's a less than and not or equal to, so I'll use a parenthesis. Is there any other place?
Isn't it still less than 0 there though?
Is 0 less than 0?
No, I'm right there though.
I can't tell where you're pointing, just so you know.
In between negative 3.
Oh, for sure. We're not done.
No, the one before that.
Here?
Plus that, yeah.
No, it says positive.
What value are we talking about? An x value or a y value?
We're looking at when is the function negative, is what this is asking. So we're looking at the y values.
Okay.
And we're saying between these x values is how we're answering it. So this one is definitely negative because I can see that. Where else? Between what?
Negative plus.
To where? Okay, how do I tie these two intervals together? Not a marriage,
Oh yeah.
a union. Cool. Okay. For this weekend, and I wish we had class 5 days a week because I don't really want to give you an assignment, but we need to finish stuff so that people can take finals, like realistically. Okay, I'm going to give you an assignment, and let's do Monday. So easy. So let's see, we're in 3.5. So here we go, homework 3.5. I want you guys to do problems. What's up? 156, or at the end of 3.5 is really all that matters. But 156, I think. Check the topic number and all that stuff. Trust that more. I want you guys to do 12 through 16. And 19 through 23 odd. I guess I can just write 19, 21, and 23. That's easier. Cool. On Monday, you guys have a wonderful day. I'm going to get games started and figured out. And catch you cool cats and kittens later.